Okay, question 7. Integration by substitution. He's kindly given us the substitution. So we are trying to integrate the integral of sec to the nx tan x dx from 0 to pi over 3. Okay, the substitution we are given is u equal to sec x. Now definitely guys, you want to differentiate this. Always differentiate the thing, the u. So du dx is, the derivative of sec x is in the formula booklet. It's sec x tan x, which is actually quite nice because that's going to fit in quite neatly here. Okay, I'm going to now change this into the integral. So this equals the integral. I'm going to leave the limits for the time being because I don't know if I want to change the limits or not. I'll decide after. So du dx is this. So dx, the way I like to do this, guys, is I say, okay, dx is then equal to du divided by sec x tan x. That's just rearranging, multiplying by dx and dividing by this. Okay, so sec x tan x. So this is sec to the nx tan x, but u is sec x. So what we're actually going to have is we're going to have a sec x to the I'll have a sec x times tan x, and then I'm going to have a sec, because I've taken out the sec x, if you like, I'm leaving a sec x tan x, but this is sec to the power of nx. So here I have to have a sec to the power of n minus 1x. Okay, now let me try and explain that. Because, well, look, if I multiply sec x by sec to the n minus 1x, I get sec to the nx, because that's like to the power of 1. Okay, then my du, or sorry, my dx is, let me just put a line here, my dx is equal to this, du over, and I'm going to put over here, du over sec x tan x. I guess, guys, I could just put this over the full thing. Okay, now the nice thing is these cancel. This cancels with this, this cancels with this, this cancels with this, and this cancels with this. But this is equal to the integral of u to the n minus 1 du. Because sec x is u. U is sec x, so sec to the n minus 1x is u to the n minus 1. Okay, now at this point I could just change the limits. In fact, let's just do that now. If u is sec x, so u is sec x is actually 1 over cos x. That's what sec x is. It's 1 over cos x. So when x is 0, u is equal to 1 over cos 0. Cos 0 is 1, so that's equal to 1. When x is pi over 3, which is the upper limit here, u is 1 over cos pi over 3. Cos of pi over 3 is 1 over 2. So this is actually equal to 2, because it's 1 divided by 1 over 2, which is 2. Yes, you need to know that without your calculator. So this is 2. So my upper limit is 2 and my lower limit is 1. Okay, now it's a fairly straightforward integral. I just need to raise this power by 1, so it becomes u to the n, and divide by the new power, so it's u to the n over n. U to the n over n. And then I just have to sub in my limits. So it's 2 to 1. So this is equal to 2 to the n over n minus 1 to the n over n, which is equal to 2 to the n minus 1, because 1 to the n is 1 over n. And that's it. That's the answer. Yeah, certainly not an easy question, guys. The main little kind of trick was this thing here. Once you got that right, I think the rest of it was fairly straightforward. If you wanted to change it back into sec x at this point, and you could keep the same limits, you'd still get the exact same answer. Okay, that's it, guys. That's question 7.